recommend that you take a look at this again. So we'll start with the oculomotor, which is this. And a quick reminder, because I was asked about this a little earlier, the final will be cumulative. I mean, it's mostly going to be this newer stuff, but I got to throw some of the older stuff to keep you honest. Okay, oculomotor nerve. It's cranial nerve number 3. It is one of the cranial nerves that moves the eye. The other 2 cranial nerves that move the eye are what? If you go back to the slides that we have coming up, cortex. That's going to be trochlear and abducens. Okay. Again, our highlighting is a little off. Oculomotor nerve is down here. Okay, the oculomotor nerve is going to come out on the ventral side of the midbrain. Now, a little while ago, I said there was a structure there that had motor fibers. What was that structure? Ventral side of the midbrain, motor. What was that? Yeah. Cerebral peduncle or crude cerebrum. Okay, those are motor fibers. Why do I want you to know that? Well, a lot of reasons, but for this purpose, the oculomotor nerve comes out right between them. There's a little pit there called the interpeduncular fossa. Inter means between. So it comes out between the peduncles. The oculomotor nerve is going to be the biggest of the 3 nerves that control eye movement. It will do the most work. And for me, if you can understand the one that does the most work, the other 2 should be simple. Should be. You know, some people might not think so. Extraocular nerves. What we have listed here are the cranial nerves that control eye movement. Depending on what your source is, you have some sources that would include the ophthalmic branch of the trigeminal because it goes into the orbit also. But these 3 nerves will serve our purpose here. So they are going to go to muscles that move the eye, oculomotor, trochlear, abducens. The nucleus for the oculomotor will be located in the midbrain. The nucleus for the trochlear will also be located in the midbrain. The nucleus for the abducens will be located in the pons. The fibers on the right side that you see, these are ascending fibers. Ascending, they're going up. That's called the medial longitudinal fasciculus. That's going to match up head movement with eye movement. So, here's our nerve 3, oculomotor. Goes to medial rectus, superior rectus, inferior rectus, and inferior oblique. There is another muscle it goes to, not listed here. It's called the levator palpebrae superioris. Levator palpebrae Cranial nerve number 4, the trochlear, goes to our superior oblique. Our abducens goes to the lateral rectus. Okay, this picture shows inputs to the nuclei. But basically what we want to know is location of the nucleus and the nerves coming out. Here's your medial longitudinal fasciculus descending out. There's an area, this is more just for your information, there's an area in front of the motor cortex. The motor cortex is right here, then you have like a supplemental motor area. There's an area here called the ocular eye field that will help control these nuclei that innervate eye muscles. Ocular eye field.
Said the nuclei of the oculomotor and trochlear are in the medulla.
I'm sorry, no, they're in the midbrain.
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 And then that sense nucleus on.
It's in the pons. Oculomotor nerve, the fibers are considered general somatic efferent. The muscles that control eye movement are similar to other muscles in your body. Okay, that's why we get general somatic. The muscles they innervate, superior rectus, inferior rectus, medial rectus, and inferior oblique. And then we said there was that one other muscle that has the eyelid called the levator palpebrae superioris. Oculomotor nerve also has a parasympathetic function. The nucleus is called the Ettinger-Westphal nucleus. It is located very close to the oculomotor nucleus. As anatomists, we're trying to get away from using people's name in the naming of objects, but you still see Ettinger-Westphal in enough literature that you'll still see it around. The more appropriate name is accessory oculomotor nucleus. So Ettinger-Westphal is the same thing as accessory oculomotor nucleus. Okay, there's two things it's going to do. One, control how much light gets in, so it can constrict the pupil. Two, it's not listed up here, but it's going to focus the eye. Now the sympathetic carotid plexus is going to have the opposite effect. Okay, sympathetic plexus is going to dilate the eye, make it bigger, the pupil. It will also change, working sort of against what the Ettinger-Westphal is doing. It's going to change the shape of the lens. Okay. Here's a brainstem. Here's the actual size. Probably not because it magnifies from the projector. That would be an awful big brainstem slice. Okay. The blue line shows you where they're cutting it. Right? A general stain is used here. The dark areas are areas of fibers, so the darker, the more fibers. Couple things landmark-wise we want to look at. Little hole in the middle, cerebral aqueduct. Surrounding cerebral aqueduct is periaqueductal gray. Peri means surrounding. So, in the name. CP is cerebral peduncle. Okay, so let's go back to our periaqueductal gray. If we look at the ventral side of the periaqueductal gray, it's pinkish, forms a V shape. That's your oculomotor nucleus. That's your oculomotor nucleus. Right next to it, dark purple, that's your medial longitudinal fasciculus. Those were the ascending fibers I mentioned earlier. Okay, they should be close to the nuclei they go to. So, the pink, oculomotor nucleus, oculomotor nerve fibers are then going to leave and come out. See these purple streaks? These are fibers that will form the oculomotor nerve. So they pass down ventrally, exit between the two cerebral peduncles. One other structure I want to show you before we leave this slide. Okay, go back to our oculomotor nucleus. In between, it gets a little darker. That's the accessory oculomotor nucleus, or the integer Westphal nucleus. It almost looks like it's a single structure right in the midline, but it's actually two structures on either side of the midline. Okay, so, accessory oculomotor nucleus, then it gets a little lighter for the oculomotor nucleus, then it gets a little darker for the medial longitudinal fasciculus, and the fibers curving ventrally are the oculomotor nerve fibers. Sorry about this picture. It will innervate superior rectus muscle, medial rectus muscle, inferior rectus muscle, and the inferior oblique. Okay, here's a side view, and again, sorry about the picture. Here's the lateral rectus. That is not innervated by three. Yellow is the optic nerve. And then if you go, it's what we call looking deeper. That's your medial rectus. That will be innervated by oculomotor. Superior rectus, oculomotor. Inferior rectus, oculomotor. Inferior oblique, oculomotor. And we mentioned another one. Here it is, levator palpebrae superioris. That is going to be the top muscle. This, yeah. Okay, so eye movement, superior rectus, elevates the eye. When we talk about eye movements, there's two ways to talk about them. One way is clinical, which is sort of what you get when you do your H test. And we'll have a picture But what happens when you're doing that is you've got several muscles working together. Several muscles working together. Okay, and you have that throughout most of your body. Most muscles do not work alone. They have friends to help them. Musculoskeletal, are you taking that in? Next quarter, probably. What you'll learn when you take musculoskeletal is that you tend to have a primary mover and then some synergistic muscles. The synergistic muscles are the helpers. And there tends to be antagonistic muscles which work against the good results. They'll work against the primary mover. Okay, so that's one way we look at movement. The other way, the anatomical way to look at eye movement is anatomists will look at the individual muscle. They will look at the origin, which will be like the anchor, and the insertion. The insertion is going to be what moves toward the origin. Okay, and you'll get more of this next part. I'm just trying to set you up for something. Okay. So we look at origin, insertion, and then movement. But it's only the movement of that one muscle. Okay. Where is that insertion going? What direction is it going? So what they've done here with rectus muscles, all of them except the lateral rectus, their origin is on the medial side of the cartilaginous disc. So the medial side. So superior rectus, it's superior, so it's going to move the eye up. But because its origin is medial, it also moves the eye medially. So up and in. Okay, that's if it's working all by itself. That's superior rectus. Inferior rectus moves the eye down because rectus muscles attach their origins on the medial side, so it's going to go down and in. Down and medial. Medial rectus just moves the eye medially. And abducts the eye. Inferior oblique. One of the things about the oblique muscles is that they run through a little connective tissue loop. And so instead of attaching to the front of the eye, they end up attaching to the back of the eye. And so when it contracts, it's going to move back of the eye down. So if the back of the eye goes down, what happens to the front of the eye? Goes up. Okay? And it's also going to end up going laterally. So up and lateral. And then our last one here is the levator palpebrae superioris. Lifts the eye. Lifts the eye. Okay, this picture comes from a book by Evelyn. I can't remember the last name. But it's called like a primer of neuroanatomy. Pictures are all fairly simplistic like this. Library had copies of this. I don't know if they still do. What I like about this picture is you get a look at the brainstem. see where your nuclei are. Okay. This little bump here, which is the landmark, this little bump is superior colliculus. So these nuclei are due to that. We've got our oculomotor nucleus and Edinger Westphal nucleus right up there together. Right. Down low, we have a cross section, which is similar to what we saw before on the stain section. So we have our oculomotor nucleus, Edinger Westphal. We see the fibers passing between the two cerebral peduncles. And here's a sagittal section. And look for my landmark, superior colliculus. These are Edinger Westphal and oculomotor nuclei. Together they form oculomotor nerve, exits between the two cerebral peduncles. It will enter the orbit through the superior orbital fissure. It also splits into a descending branch or inferior division and a superior division. Okay. Superior division goes to three things. Superior division goes to three things. One, levator palpebrae superioris. Two, superior rectus. Three, ciliary ganglion. The ciliary ganglion is going to be the parasympathetic part. The inferior division also goes to three things. Medial rectus, inferior rectus, and inferior oblique. Two divisions, each division goes to three things. Okay. Oculomotor. What this picture is telling you is that it helps keep your eye open. Okay, levator palpebrae superioris. So the mnemonic for this is it's like pillars keeping your eye open. All right. Facial nerve. Facial nerve is facilitated going to the muscles that surround the eye. So one of them is called the orbicularis oculi. That's what closest your eye. So this mnemonic is equating the facial nerve with little, as being like a little hook. And so the hook grabs your eyelid and pulls it down. Okay. If that works for you, great. Go with whatever works. As silly as they may be. And typically the sillier the better. At the bottom here, this is what they call the chemical formula. Lateral rectus LR6, that's abducens. So the abducens nerve innervates lateral rectus. SO4, that's superior oblique, trochlear nerve innervates superior oblique. And typically, what I've seen is there'll be like a little division line for O3. O is others, and 3 is oculomotor. So oculomotor does all the others. And again, if that helps you, by all means. Autonomic control, and really the parasympathetic part, again, controls the amount of light coming in, focuses the lens. far as light comes in. And if you recall from last week when we talked about the optic tract, we said it's split into two branches, medial and lateral. The lateral side is what went to the visual cortex. The medial side is going to this pretectal region. What's important about the pretectal region is the pretectal region that goes bilaterally to both sides. Bilaterally to both sides. Okay, so it goes bilaterally to both Ettinger-Westphal nuclei, which then go to ciliary ganglion. And this is the oculomotor nerve to ciliary ganglion. Coming out of the ciliary ganglion, these fibers are called long ciliary nerves. Sorry, short ciliary nerves. Short ciliary nerves. And in this case, as far as constricting the pupil, it's going to constrict their pupillae muscles. Makes the pupil small. Which side is it going to make it smaller?
Opposite side.
Both. Yes. Both sides. That's the pretectal region. Goes bilateral, both sides. Okay, we can do a quick demonstration if somebody wants to get the light, turn the light on. If you have a light on your phone and a little neighbor, okay, only do it if neighbors are okay with it. Shine the light, get the light dark enough. Yeah. Yes, it'll dilate. Prove me wrong. Yeah, so apparently people don't want to try. There you go. So if you have a light on your phone or you just carry a light around with you and your neighbor's willing, if you shine the light in one of their pupils,
Sure, why not? I
you
flash
notice
me.
that both of them get small.
I said, definitely, that's what I said. Or in the dark, no one will see.
Is it working? Is it working?
Cool.
Hold the light away.
No way.
Oh, yeah, there it goes. Yeah, that is freaky.
Good job, Cole.
You should see
Good
both
job, we're getting
pupils get small.
freaky and flashing each other in the dark.
When you hold the light away, you should see the pupil getting bigger again.
Why is your flashlight so gentle and mine's just kind of like...
I turned mine down.
Oh, you can do that? I didn't know that. God, I moved. Fancy.
Yes.
Isn't
Yeah, we're not going to talk about you can your bloodshot.
when eyes dilate, that's a sympathetic response though.
Yeah.
So when she just mentioned when you look at someone who's like sweat or whatever, if you dilate, isn't that why would you be having a fight or flight response to that?
Well, because sometimes you get nervous.
Got it.
Yeah, that's literally a fight or flight response. You girls make me uncomfortable.
Fair. Am I scary?
Hmm?
Am I a scary
you can turn
person?
the lights back
Fair.
on if you want.
That's the
So that's
funniest
the
thing.
Oh,
parasympathetic.
God, don't.
Oh.
So that's the parasympathetic response. The bottom part of the picture is showing you the sympathetic. And you've got spinal cord, the cervical part of the sympathetic trunk, which was paravertebral. It's going up to our superior cervical ganglia. There's a little plexus of nerves going around carotid artery, called the carotid plexus. This is going to join up with the ophthalmic division of the trigeminal nerve. And this is going to be the sympathetic part. So this is what's going to make the pupils dilate. Okay, so all we just did is written up there. Okay, here's the same thing, but diagrammed out. So you see the fibers coming in from the optic nerve, optic tract, pretectal area. You can notice bilaterally, so you get both sides involved. Drawing a little picture like this is helpful so that you can sort of think about questions like, what happens, or which eye is affected if there's a lesion in the optic tract? Okay, well, this is going to affect both sides. If the lesion in the optic tract would affect both sides. What happens if there's just a lesion maybe in the anterior westphal on one
Bless you.
side? Well, that's just going to affect that side. Okay, what about a lesion in the oculomotor nerve? Okay, it will affect the side that the lesion is on the oculomotor nerve. I don't have a great picture of what happens for focus accommodation, but it's going to work differently. For accommodation, what happens is you get your image, it's the retina, then it's going to follow the visual pathway all the way back to the occipital lobe, to the visual cortex. And the visual cortex will notice something's not right here, it's out of focus, it's all fuzzy, and it will send a message. It will send a message back to the anterior westphal nucleus. And then from there we follow back to the ciliary ganglion and short ciliary nerves. This time it's going to go to ciliary muscle. And ciliary muscle is going to be attached to the lens. So the muscle constricts, but the fibers that actually go to the lens sort of weaken. And so the lens is going to bend out more and help with focus. Okay, so that pathway would be sending fibers way back here to the back of the head. All right, midbrain, internal anatomy, this is here to show you the location of our oculomotor nucleus. It doesn't have the anterior westphal here, but you've got your medial longitudinal fasciculus, fibers going between our two cerebral pedoncles, so these are your oculomotor fibers. Okay, and then listed off to the side, we do have some other things. I think we've seen this before. Red nucleus, they call it red. Substantia nigra, right above our cerebral pedoncles or crus cerebri. This one is a little further back. It's still midbrain, but at this level, instead of superior colliculus, we've got an inferior colliculus. Back up. Superior colliculus. Inferior colliculus is going to be associated with the trochlear nerve. Are you good with those pictures? Trochlear nerve is coming up, so we don't need to spend a lot of time with that picture yet. damage to cranial nerve 3. Normal eye, abnormal eye. If you damage cranial nerve 3, yeah. Excuse me. You have the tendency to look down and out. Ptosis, that means again, it's hard to lift. Okay, remember cranial nerve went to that levator pelvic superior oris, so you can lift your eye. Decreased tone of constrictor pupillae muscle. So the pupils stay dilated. Let's see. Doesn't really say it here, but your eyes will dry out a little bit since you can't lift the lid. Paralysis of pupillary accommodation. So cranial nerve 3 palsy, pupil involved, trauma, and then tumor, pupil
sure.
repair. That tends to be a vascular issue. And really, I think aneurysm is a major cause. Sometimes you can get the cerebellum permeating into the area and compressing your brain. Questions? My day was good so far. Good. Okay, all we have left for this week is trochlear and abducens. So, go ahead and go on break, but make it like 36 hours. Yeah, we'll just finish this, come back on Thursday and do those 2 notes.
Sweet.
We love Mercy.